Assalamualaikum and hi everyone. We are now in Lecture 8, Distributed Database Management Systems, DBMS Part 3. At the end of this lesson, you should be able to explain the concept of allocation in centralized, fragmented, complete and partial replication of distributed relational database design and explain the horizontal, vertical, mixed and derived fragmentation together with its correctness rule. In this section, we will examine the additional factors that have to be considered for the design of a distributed relational database. The first one is data fragmentation. A relation may be divided into a number of sub-relations called fragments, which are then distributed. The second one is data replication. The DBMS may maintain a copy of a fragment at several different sites. And the third one is data allocation. Each fragment is stored at a site with optimal distribution, or what we can say, where do we want to put the data. Let's take a look on fragmentation. The definition and allocation of fragments are carried out strategically to achieve the following objectives. The first one is locality of reference. Where possible, data should be stored close to where it is used. If a fragment is used at several sites, it may be advantageous to store copies of the fragment at these sites. The second one is improve reliability and availability. Reliability and availability are improved by replication. There is another copy of the fragment available at another site in the event of one site failing. The third one is improved performance. Bad allocation may result in bottlenecks occurring. There is a site may become inundated with requests from other sites. Next is balanced storage capacities and costs. Consideration should be given to the availability and costs of storage at each site so that cheap mass storage can be used where possible. Last one is minimal communication costs. Consideration should be given to the cost of remote requests. Retrieval costs are minimized when locality of reference is maximized or when each site has its own copy of the data. There are 4 alternative strategies regarding the placement of the data, which is data allocation. The first one is centralized. This strategy consists of single database and DBMS stored at one site with user distributed across the network. The second one is fragmented or partition. This strategy partitions the database into disjoint fragments, with each fragment assigned to one site. If data items are located at the site where they are used most frequently, locality of reference is high. Next is complete replication. This strategy consists of maintaining a complete copy of the database at each site. Therefore, locality of reference, reliability and availability and performance are maximized. Last one is selective replication. This strategy is a combination of fragmentation, replication and centralization. Some data items are fragmented to achieve high locality of reference and others, which are used at many sites and are not frequently updated, are replicated. This is the comparison of strategies for data allocation. We will have centralized, fragmented, complete replication and selective replication against locality of reference, reliability and availability, performance, storage costs and communication costs. It depends on which strategy do you want to implement for your business, as long as it serves its purpose. Let's move on to reasons for fragmentation. The first one is usage. In general, applications work with views rather than entire relation. Therefore, for data distribution, it seems appropriate to work with subsets of relation as the unit of distribution. The second one is efficiency. Data is stored close to where it is most frequently used. In addition, data that is not needed by local applications is not stored. The third one is parallelism. With fragments as the unit of distribution, a transaction can be divided into several subqueries that operates on fragments. Last one is security. Data not required by local applications is not stored and consequently not available to unauthorized users. Let's take a look on types of fragmentation. The first one is horizontal fragmentation. It consists of a subset of the tuples of a relation. or we can say we divide our relation by row. The operation that can be done on horizontal fragmentation is sigma predicate relation. Predicate is the condition and relation is the table name. Second one is vertical fragmentation. It consists of subset of attributes of a relation. Means we divide our relation by column. The relational algebra operation is pi, attribute 1 up until attribute n, and the relation name. Next is mixed fragmentation. It consists of a horizontal fragment that is vertically fragmented, or a vertical fragment that is horizontally fragmented, or what we can say it is a combination of horizontal and vertical fragmentation. The relational algebra operation would be sigma predicate, then we project a columns that we want from a relation, or we project a columns that we want, then we choose a row from the sigma from the relation. Next is derived horizontal fragmentation. We can say this one as a double horizontal fragmentation. Okay, it is a horizontal fragmentation that is based on horizontal fragmentation of a parent relation. Okay, the relational algebra would be relation 1 semi-joined with relation 2 on a joint condition. The last strategy is no fragmentation. We will not fragment a relation that has small number of tuples and not updated frequently. So I guess that's all for now. See you again in the next part. Thank you.